Hello and welcome to Maths by SAS. This is my first lesson of D3 chapter number 8 exercise 8b, that is about area of triangle. In this lesson we'll be discussing that how to find the area of oblique triangle. But before moving to the lesson, I just want to wish a Merry Christmas to all of my Christian fans and friends, and a very happy winter break to all of my students. Students, enjoy your winter break, but do not forget the math lessons. We all know that we are taking these classes due to COVID-19's gap so that we can bridge and we can cover up the gap of those classes that we have missed due to the COVID-19. So let's move to the discussion of today's class. In today's class, we have to discuss that how to find area of non-right or oblique triangle. Before going to the lesson, there are some key terms that we have to understand first. That we know that area of right triangle is half base into height, but when the triangle is not the right angle triangle or triangle is the oblique triangle, in order to find the area in such case, either we have to apply the formula that area equals to half AB and sine C, two sides and included sine of included angle, or we can apply formula that is area equals to S into S minus A, S minus B, S minus C, and then we have to take the square root of that, where S equals to A plus B plus C, where A, B and C are the sides, and we have to find the sum of the sides and we have to divide that sum by 2, or in other words, in order to find the area, we will be using the Hero's formula, which is equal to S into S minus A, S minus B, S minus C. We have to multiply them, and then we have to take the square root, where S is the half of perimeter. I hope you are clear about this discussion, and let's move to question number 1, basic level. Question 1 says, find the area of following triangles. And if we look at the first case, in the first case the given triangle is AB and C, where we are given with AB side 8 centimeter, AC is 9 centimeter, and the angle is 72 degrees. I hope students you remember that we discussed this thing in our previous lessons as well, that the sides will be marked with opposite small letters, like this is side A, this is side B, and this is side C. Now we know that formula for the area is half. Now look, we have to make changes in the formula according to the letters of the sides. Now this is the angle is given between the side B and C, so we will be using the formula half BC and sine of angle A. And now very easy, what we have to do, we just have to replace the values carefully. Half into B is 9, C is 8, and sine of 72 degrees, sine 72 degrees. And now we know that, okay, first let me take the sine of 72 degrees, sine 72 degrees. Remember that your mode of calculator must be on the degree mode, and this will give me 72 by 2 multiplied by 0.95 and 10, and then what I have to do, it's up to you, like 2 and 72 to 36 times, and now 36 multiplied by 0.95, 0.9510, 36 multiplied by 0.9510, and this gives me 34.236 units square. And as we have to take the answer nearest to 3 significant figures, so 34.2 and centimeter square is the answer for this question. Moving to B part, and in the B part the triangle which is given to us is having the vertices DEF. Now first thing is that we have to label opposite lengths, as EF is the side in front of the vertex D, so it will be D, and this is F. And now recall the formula for the area of oblique triangle, that area equals to half. Every time we will not be using AB. Now this is the length FD, and included angle is sine E. Very easy questions, and I hope my children can easily do these questions. Half into 7 into 9 and sine of 111 degrees. 9 times 7 is 63 by 2, and now I have to check sine 111. Sine 111 degrees is 0.933, 0.933 and 5. Now it's up to you. Either you can simplify 63 by 2 first, or what we can do is that 63 multiplied by 0.9335, and this gives me 58.8105, and then I have to divide this answer by 2, divided by 2, and this gives me 29.40, 29.40, or which can approximately be taken as 29.4 and centimeter square. Moving to C part. In C part, the triangle which is given to us has the vertices G, H and I, and G to H side is 9.5 centimeter, and H to I side is 10 centimeter, and angle at vertex is 57 degrees. Now students, look at the diagram carefully. We know that in order to apply area of oblique triangle, we need the angle which has to be between two given sides. But in this case, the angle of the included sides is not given. So what we have to do, we know that sum of interior angles of triangles is 180 degrees. So first of all, we have to find value of angle H, and that will be equal to 180 minus 62 plus 57. Very easy. If the concepts from the junior classes and D1 are clear, you can easily solve these questions. Okay, 162 plus 57 will give me 7 and 2 9, and 6 and 5 is 11, 119 degrees. Okay, take it away from 180, and this will give me 180 minus 119, and this gives me 61 degrees. 61 degrees. Okay, now what we have to do is, this angle is of my 61 degrees. Now let me quickly add up the angles, and if they are making it 180 degree, it means my calculation is correct. 62 plus 57 plus 61, 180 degrees. And now we have the angle which is in between these two sides known to us. Now we can apply the formula. Now look, this vertex is G, so this length will be G, and this vertex is I, so opposite side will be small I, and formula for the area is half into G into I. Dot stands for multiplication and sine of 61, sine of angle H. And now replace the values, that is half into 10 into 9.5 and sine 61 degrees. Okay, let me check the value of sine 61 degrees, and that is 2 times 10 is, okay, 10 how many times, 2 how many times is suitable for 10? 5 times. 5 multiplied by 9.5. 9.5 multiplied by 0.8746. Now what we have to do, we have to multiply these all numbers carefully. 5 multiplied by 9.5 multiplied by 0.8746, and the answer comes 41.54, or approximately area will be equal to 41.5 meters square. Yes, the dimensions are in meters, so I'll be placing meter here. Okay, very easy questions. And let me move to the next part. And in the next part, the given triangle is having the vertices JK and L, and angle at vertex L is 28 degrees, J is 105 degrees. Let me mark the angle here, 105, and JK side is 6.5 and K to L side is 13.35. Now the question says that we have to find the area. In order to find the area, we know that we are given with these two lengths, so angle in between these two lengths must be given to us, but it is not already given. So recall that sum of interior angles of triangle is 180 degrees. And now in order to find angle K, what we are going to do is we have to take away the sum of 105 and 28 degrees from 180. 105, yes, this is 105 plus 28. Okay, so let me check what comes. 105 plus 28, and this gives me 133. Okay, K, 180 minus 133 minus 180, this is 47 degrees. 47 degrees. Okay, let me replace the angle 47 degrees here. And now if I'm adding 47 plus 28 and 105, answer is 180 degrees. So it means that calculation for angle is correct. And now what we have to do, we have to apply the formula for the area, that two sides and included angle. Now look, this side is in front of J, so it will be marked with small j, and this side is L, so area will be equal to half J dot L dot sine 47 degrees, and this is half into 6.5 into 13.35 into sine 47 degrees, sine 47. Okay, and this is 0.7313, 0.7313. Now what we have to do, we have to multiply all the values of numerator. 6.5 multiplied by 13.35, and I have to multiply that by 0.7313, and this gives me 63.45, 63.454585 divided by 2. Now I have to divide this answer 63.4585 by 2, and this gives me 31.72. 31.72 meters square. I hope you are clear about this question, and let's move to the next question. The next part, and in the next part we are given with a four-sided shape. We are given with a quadrilateral, that is M and O and P, and length along M to N is 5.8 and length along M to P is 5.3. As we are given with the parallelogram, so we know that we can divide the parallelogram into two triangles by drawing the diagonal here. Now as we know that opposite angles of parallelogram are equal, so in order to find the area of this parallelogram, area of parallelogram will be equal to area of parallelogram and what is the name of that? M and OP. M and OP will be equal to 2 times area of triangle MN and P. MN and P, and what is the reason? Because both the triangles will be same. This side is parallel to MN, so it will be 5.8 and this will be 5.3, and the angle on A will also be 117 degrees. So instead of finding the areas of two triangles separately, what we have to do, we have to find the area of one triangle and we have to multiply it by 2 to get the area of a whole figure MNOB. So area will be equal to 2 into, I think now we have enough practice. Even then, let me write the letters here for the lengths. This is P and this is N. 2 into half of this is NP and sine of angle M. And now what we have to do is, first let me replace the value half 5.3. 5.3, this is multiplication sign, multiplied by 5.8 and sine 117 degrees. 117 degrees. And now look children carefully, try to learn to make your calculations easy. This 2 can easily go with 2 and I'm left with 5.3 multiplied by 5.8. 5.3 multiplied by 5.8 into sine 117. Sine 117 has the value sine 117. 117 will give me 0.8910. 0.8910. Now I have to multiply these all numbers. 5.3 multiplied by 5.8 multiplied by 0.8910. 0.8910, and this gives me 27.38 or approximately 27.4, and the measurements are in centimeters, so it's centimeter square. Let me check calculation once again. 5.3, first let me press sine 117, and this gives me 0.8910 multiplied by 5.8 multiplied by 5.3. Okay, 27.389. Okay, moving to the next part, and in the next part again we are given with a four-sided shape, and in that four-sided shape we are given with only one side, that is 8.5 meters, and one angle, that is 78 degrees at vertex Q, and rest, if we observe the diagram carefully, we can see all sides are identically marked. So recall that what four-sided shape has all sides of equal measure, but angle is not of measure 90 degree, that is rhombus. So it means if it is a rhombus, then all sides will be of same measure, and that is 8.5, 8.5 and 8.5. Again, the rule will remain same, that area of this rhombus will be equal to the area of two triangles. And what we can do is to make the question easy and for better understanding, we can do is that we can divide this rhombus, this quadrilateral, in two triangles. So area of QRST will be equal to 2 times area of triangle TQR. T, Q and R. And now first what we have to do is, as this is QR is the length in front of the vertex T, so this will be small t and this will be small r. Now this will be equal to 2, and area of triangle is half, and TR and sine of Q. Now this 2 can easily be going with this 2. Let me remove this, and then I'm left with TR and sine Q, and T has the value 8.5 and R has the value again 8.5. Because it's a rhombus, all sides will be of equal measure, multiplied by sine 78 degrees. Okay, so sine 78. degrees is 8.5 multiplied by 8.5 multiplied by 0.9781. Now what I have to do, 0.9781 multiplied by 8.5 multiplied by 8.5, and this gives me 70.66 or approximately 70.7, and the measurements are in meter, so a meter square. Okay children, I hope you are really clear how to find the area of oblique triangles and quadrilaterals. For better understanding of next lesson, please catch me in the next class. Watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.